In Java, the for loop is used to execute a block of code a specific number of times, just like your for loop, your do while loops. These are all control structures that allows you to iterate over a block of statements. The for loop is particularly useful when the number of iterations is known before the loop starts executing. As you can see here on the left side, the anatomy of a for loop calls for this block of segments: the initial action, the loop continuation conditions, and the action after each iterations. So let's take a look. You start off with initial actions. And this initial action simply is just the initialization step of your looping structure. And just like your while and do while loop, it checks to see whether the condition is true or false. At this point, if true, then a whole lot of stuff is evaluated or executed. This typically, in the context of a for loop, means increment or decrement, which is basically the counter that keeps track of how many iterations you have left based on the condition. After that action, you're going back to the very next iteration, continuing with the condition check, and rinse and repeat. If condition is true, you just keep going like this until you're done. Right before you're done, your condition has to be false. This would actually take you completely out of your for loop, ending the iteration. Let's talk about this in a more concrete way, looking at this example. Let's start off with the decision tree. So I equals 0. I is an integer, checking to see if the condition is true or false. If I is 0, is I less than 0? And the answer is yes. Then it prints welcome to Java to console. And then the action after that will be to increment your initial counter I. You may also increment your counter using a prefix I. It doesn't really matter because there's nothing after that other than taking you back into another conditional check. And since this conditional check is the next statement, your I would have been incremented anyway, regardless whether you have prefix or postfix. The effect for either is the same. So now I equals 1 because you just incremented it. Checking to see if I is less than 100, the answer is yes. So the loop continues until you get to the point where I becomes 100. The condition reads, is 100 less than 100? And the answer is false. At this point, when I equals 100, your entire loop stops because the condition yields false, taking your entire flow of control out of this for loop. And this is the code that represents what I just talked about downstairs. Notice that you have 3 segments inside this for loop. The very first one is initialization of your counter, semicolon. This is not your common, but semi. Please remember that. Every time we have semicolon, that means everything preceding it in a statement is evaluated. The second part or segment of your for loop condition is the conditional expression, which checks to see this is true or false. And the third segment of your for loop construct is that increment thing I was talking about earlier. Sometimes you can also decrement, assuming you want to go in the reverse direction. What it matters is really the condition and your initialization of that counter, whether you can go forward or backwards. Lastly, just remember there's a pair of curly braces that holds your entire block of code or loop body. Let's trace for loop in a very simple illustration next. This is a very simple code snippet that calls for initialization of your counter I, starting with it being 0. As long as I is less than 2, you keep on looping it. Every time you loop your body, at the end, you need to perform that one last action, which is that increment, I++. So let's start up from the very beginning. When you do integer I, what you're doing is inside this memory cloud, you're setting aside 4 bytes contiguous memory space with the label I. There's 4 bytes of memory space inside this. By default, if you do not initialize your integer variable, it has a default value of 0. So we're going to put 0 here. Let's move on to the next step. Then your flow of control goes into I equals 0. This is where I is initialized with 0. This technically is not needed since Java defaults any integer to a 0. Having I equals 0 makes your code easier to read than leaving this out. If you leave this out, it would be semicolon and there's nothing preceding it. So it looks kind of weird, but everything else stays. I++. Let's move on to the next. Your conditional is checked. Given that I equals 0, is I less than 2? The answer is yes. So your conditional evaluates to true. Next up, because the decision tree says this whole thing is true, your loop body is evaluated, which simply prints welcome to Java to your console. Next up, you have that action right there. After welcome to Java is printed, your next action is to increment I because it says I++. Technically, you could have ++I. It will have yielded the same value as I++. And notice that there is no semicolon because you're at the end of that parentheses. If you add another semicolon at the end, your code will not compile. Just remember the syntax of a for loop consisting of these three segments. Anyway, after I++, your I is going to be incremented by 1, which means I is now 1. Given that I is 1, and the fact that I is still less than 2, because 1 is less than 2, your conditional is still true, which means your flow of control goes into the loop body to print welcome to Java, as you can see here. The loop continues with that action to increment I by 1. Now I is 2. What happens when I is 2? Well, this condition gets checked. Is 2 less than 2? The answer is false. So at this moment, your conditional yields false. Remember, when you have false in a condition, that effectively terminates your loop, taking your flow of control out of this parentheses, because that is the boundary for setting up your for loop execution body. Your flow of control lands at this very next line outside of the preceding for loop, ending it. Let's do a quick summary of this. Just by looking at your control structure, remember the three segments we talked about earlier. The very first one is the initialization. The second one is the condition, which yields either true or false. And the third one is your iteration. The whole iteration could be either increment or decrement. Sometimes you also see that people initialize their counter inside the for loop. So you can have something like this, where you initialize your for loop with I equals 0 plus its declaration, all in here, I less than 2, I++. The difference between this version versus this version that you see here is I is in scope in the for loop, which means if you go outside of your for loop, I is going to be undefined because the scope of I is constrained inside this area, inside the for loop. Whereas in this version, where I is initialized outside, your I can also be used here, or here, or here. Basically, it is global to this for loop. Whereas in this version, I is local inside this loop. Either way is fine. If you want to keep reusing the same I, maybe in a different block of code, you can make it global. But just be careful of keeping track of its value because you don't want I to be anything else unintended when you start your iteration making use of it. This shall complete our discussions on the for loop. We'll look at some of the idiosyncrasies associated with the use of this type of control structure next.